Okay, so I hope everybody can see and hear me now. So before I start, just a few sentences about myself. My name is Tim Appelhans. I used to be in academia for quite a while, but then I switched to the private sector and now work at a company that is called Meter. I said this on Monday already, meter like in 100 centimeters and not that Facebook thing that everybody is talking about these days. That company is a sensor producer mainly, and we do produce environmental sensor equipment. So sensors and loggers, and we have a cloud solution, and that's where we come in as our little group within that company, because I lead the data science group there. I have two colleagues with me. One is back there, Florian Deitsch. He's also here to help people if you have any problems installing the software that I will be talking about in a while. So if you have any problems here in the room, Flo is happy to help. Now, that's pretty much all I want to say about myself. So if you want to know more about what our company does, feel free to contact me at any stage or approach me here. That's all fine. And I'm not going to do a company pitch now because we're open source, OpenGeoHub here, so not that related. The stuff I'm going to talk about today is basically my private interest or my hobby, I would say. Started when I was still in academia, and it's all about interactive visualization of spatial data in R. So I started off by creating a package that is called MapView that some of you may know already and use, hopefully. But that is rather limited to local data that you have on your computer that you just want to quickly show some or see and quickly want to check if your data is correct or if your classification went correct or things like that. So it's just for quick and dirty visualizations. What I'm going to talk about today is basically what you see here. Those slides are though not from myself. They are from a talk that was done at Phos4G in Florence last week by Matthias Mohr and Daniel Dufour. I'm hoping I'm pronouncing that name correctly. I don't know, Daniel, if you're listening, thanks a ton for all the work you've done, and thanks a ton for all the help you provided me with over the last few days. So it's all about cloud native geospatial visualization. And in this course that I'm doing here right now, it's about how to do that from R. But in the end, under the hood, this is all done in JavaScript, because that's the language of the browser, and that's where all the visualization happens. In R, we only do a little bit of mangling and preparation of the data, or in that case, we don't do any preparation of the data. We just pass a few options that we expose via the API to the R user. Those are then sent to the browser, and all the heavy lifting and all the visualization is done in the browser. Now, cloud native geospatial in JavaScript is a very hot topic at the moment. It's a very young topic as well. And geospatial cloud native visualization in general is also quite a hot topic at the moment, because there's, apart from the cloud optimized Geotiff, where I think it's safe to say that this is establishing itself as some sort of a standard, at least the de facto standard that people use most. On the vector data side, there is a lot of stuff going on, and we heard a little bit about Geoparket and GeoArrow already. We've heard, I guess, the phrase or the term flat GeoBuff already. And those are the kinds of things that I'll be talking about today. Not so much Geoparket or GeoArrow, but definitely flat GeoBuff. And from this presentation, I just want to draw your attention to the very last conclusion slide of their talk, where they basically go through a few of these data types and data structures, and whether they are actually usable in a JavaScript way or not. And their conclusion is that, for example, COG, so the Cloud Optimized Geotiff, has a good library to work with. It's good for visualization and for mapping, and it's recommended in the browser, and there's lots of documentation and examples. So this is, in the end, for raster data, I would say the de facto standard that we should use or could use. So I'll be talking about COGs today as well. Then COPC stands for Cloud Optimized Point Clouds. That is still work in progress. There's no dedicated JavaScript library at the moment. So as from an R perspective, we can't really make that usable already to the users. Kotar, I have no idea what that is actually. Then Flat Geopath is, there is a library that you can use or JavaScript bindings that you can use. It's very good for visualization and mapping. It doesn't have overviews. So if the data is too large, you're gonna freeze your browser. That is something that you always need to keep in mind when you work with Flat Geopath. We do have an R binding for Flat Geopath already for a while. And that is what MapView actually uses by default nowadays when you visualize your data, because it has this nice streaming capability so that you see your map instantly and don't have to wait until all your data gets loaded onto it, but it just streams onto the browser. And they also talked about Geoparket. There's no dedicated JavaScript binding at the moment. I think everybody agrees, or that's at least the only thing I've heard, that everybody agrees that it's not really made for visualization or mapping. It's for analysis, because it's columnar data rather, or storage rather than row-wise storage. And as we've already discussed in the discussion yesterday and touched upon in Edza's session and Leandro's session, the geo part is still work in progress, so it's not there yet to be used with geospatial data. Then OpenEO is a different thing anyway, in my mind. Then there's a file format or a data structure called Pm Tiles, and that is basically what I'm going to talk about mostly today when it comes to vector data visualization in the browser. And that gets all the tick marks, and that is actually set out to be for vector data the equivalent as cloud optimized geotiffs. And I'll show you in detail how to create those files and how to use that from R. And then stack and ZAR, I think stack is something, is basically meta information to find things in my mind, but I'm not too into, or I don't know too much about stack. And ZAR, as we heard in the discussion yesterday as well, is more or less a successor of NetCDF or re-implementation and refinement of the NetCDF standard. And that I have never seen anything in JavaScript. Yes, Edza?
I was just going to say this table. Kotar is cloud plus tar. Tar is the tar.gc.
Okay, so so for compression and
it doesn't compress. Tar is a format for putting files together.
Oh, okay.
Originally for writing dates, data.
Okay, so it's for data transfer mostly, I would assume.
Is how you package.
Okay, thanks. So Edza just said this stands for Cloud Optimized Tar, which is like a the Linux way of packing files together, like zipping in the end. Okay, so much for this. The three types of things we're going to talk about is cloud optimized geotiffs, flat geobuff, and then Pm tiles. Now, does everyone have access to the R Spatial MetaMouse channel? Is that also true for the online participants? Oh yeah, that would be nice. I put something in that channel there. Here we go. So these three links basically we would need to have shared with the online crowd because that's where all the scripts and all the documentation and all the documents are that I've been talking about today. So we have 2 slots this afternoon. So I'm going to take the first slot to show you how to visualize cloud optimized data from R. That might not take that long. And then in the second part of this tutorial, so we might start with the second part already in the first block. We'll see how that goes. But in the second part, I want to show you how to create this data that you can then visualize. And I want to stress that this is only one way of doing things. There's, as always, many ways of doing things, but this is one way, and this is basically the way that I decided to go. And that is simply because when I said I'm going to do this tutorial to Tom, when we planned this summer school, I didn't know anything about this, but I wanted to know a lot more about this. So I said, okay, I'm going to do a tutorial because then I have to learn. And you can imagine when you work, then 8 hours in front of a computer and you go home, it's kind of hard to find the motivation to do this kind of things again for another 2 or 3 hours in the evening, to sit down, open up your computer again and start coding in your free time. So bear with me. We are on our way to establish all of this functionality that is out there for the R user to be used. At the moment, we're not quite there yet. So this is basically a snapshot of what is possible at the moment. And I'll show you a few other ways, or at least one other way of doing things from an R perspective. There's a R package developer that sits in, I think in Melbourne, if I'm not mistaken, at least somewhere in Australia, called Miles McBain, and he does a lot of stuff in that realm as well. And he has a really nice blog post that I'll show you later on how to do things a little bit differently with not using Leaflet, but using a package called RDEC, which is DECGL from R, which is supposed to be a lot more performant, but then in the end, I prefer Leaflet, just simply because. So, all right. The 2 packages that you will need to do the visualizations are package Leaflet and package Leafem, which is a package that basically enhances Leaflet in certain ways. Mainly, it adds some extra functionality to it, like mouse coordinates that you can show in the browser where your mouse is, zoom to layer buttons and all that kind of stuff that has been there for a while. And in that package, we now have a new function that is called add cork. One thing regarding the Leafem package, because I worked on implementing this until last night, you will need to install it from GitHub. So remote install GitHub r-spatial/Leafem should get you the latest version with which all this should work. As I posted that earlier, I think GitHub said for many people, you can't install it at the moment because there's too much traffic. So if you try again now, it should work. And if it doesn't, maybe wait another 5 minutes and then it should work again. So even I couldn't install it when I posted that because I wasn't allowed. Too much traffic there. So I'm assuming that most of you have already installed this according to the instructions in the MetaMask channel. So cloud optimized Geotiff has been talked about quite a bit in this summer school, so I'm not going to go into too many details regarding this. But what I've done basically is, or the way this works is, there's a lot of pre-processing. So far, my approach to visualization in R was always, I have something in memory and I want to see it quickly, right? So I'm just going to send the data from the R session to the browser and then visualize it. When it comes to really large data sets, that pre-processing takes time. There's no way around this at the moment. So you will need to spend some time in order to pre-process your data to make it cloud optimized. And I guess Tom knows exactly what I'm talking about with his millions of layers of 10 meter, 30 meter resolution worldwide data. Creating those cloud optimized geotiffs just takes a little bit of time, and you need to prepare those to have that really nice performance and usability then in the browser. And I mean, if you go to Open Land Map, that is so responsive, that is really, really nice. So
that's just GeoServer on steroids.
GeoServer.
Yeah.
Okay.
Yeah.
Okay.
On steroids.
On steroids. Okay.
Yeah, you tweak some parameters to reduce all of parameters. So you use the server just for visualization.
Okay. So it involves a lot more setup. It involves a lot more hardware and all that kind of stuff. What I'm going to show you today is you don't need any hardware. You don't need a lot of setup. The only thing you will need in order to reproduce everything that we're doing today is an S3 bucket on Amazon Web Services, where you host your data, basically. That's where you store your data. And then from R, you can directly read it from the S3 bucket into your browser session and visualize it. So that's what this whole tutorial will be about. So I created and there's a free tier for up to 5 gigabytes of data where you don't pay a cent to use an S3 bucket. And after that, it's really, really cheap. It's like a couple of, or not even a couple of cents, it's like 0.01 cent for a gigabyte of storage or something. It's really, really cheap. So pretty much everyone should be able to afford this. So I've created 15 cents of cost over the last month with this data. So this is nothing really, right? So I've created a few buckets there actually to be just to be a bit more organized. So this is what they look like. There's one for cloud native data creation. There's one for cloud native raster data viz, one for cloud native vector data viz, and then there's one where I just store a map because you can host and serve HTML files directly from an S3 bucket as well. So you don't have to go via your computer at all. You can just host it all online on S3 and just share the link with your collaborators that you want to show your results to or whatever, or put it in a blog post or put it on the web and say, look, this is what I've done. And then there's 2 buckets with the data actually. So if we go in here, then we see all the data sets that are in here, and they are, some are quite large, some are medium sized. So that's basically the buckets we're going to work with. And the raster data is in a bucket called raster tiles data. You can use library pause, which is basically AWS command line interface ported to R. So everything you can do in the AWS command line interface, you can do with the pause library in R function abstractions as an API. So if you run this code, this should work, because as you can see here, I get a lot of warnings here because I have public access to all these data sets. Usually that's not recommended, but to share it with a wide group, like in this setting, I just made everything public. Otherwise I would have needed to share credentials and everything with everyone, and that is just not convenient. So I'll just made those things public, but you can only publicly read. You cannot write or edit or do anything fancy in the bucket. You can just read the data basically and list the objects. And that's what we're doing here. So if you run this code in your R script, you should see that there's 2 cloud optimized geotiffs in there of the same type. It's the same data, it's just different compressions, because I was interested in to see which or how much influence the compression has on the actual experience that you then see in the browser. So the loading times basically. And this one that is called Earth 3857 Corp Geotiff is using the deflate compression, which makes the thing a lot smaller as compared to the LZW compression, that is the standard compression or the default compression that GDAL uses to create cloud-optimized geotiffs. And that actually makes the experience in the browser much, much nicer because it loads much quicker. So those are the two things that are in there. That's the only two examples that I have for cloud-optimized geotiffs, because I thought cloud-optimized geotiffs have been around for a while now. I'm assuming many people have already used them or have come across those, but cloud-optimized vector data is something that is really quite new, and so I'm going to spend more time on the vector data rather than the raster data actually. So in order to visualize that data, the only thing, as I said, is you need the URL to the TIFF file. So this is one file that sits in an S3 bucket, and that is always basically HTTPS, and then the bucket name, S3, the region of the Amazon service, Amazon AWS.com, and then it's the name of the file. And that's it. And then you can use add cork from library Lithem. You provide the URL, and one thing you need to provide is the layer ID, because internally in JavaScript, that layer ID gets used to distinguish between different layers that you add to your map. So if you have more than one layer, you definitely need to supply the layer ID, because otherwise things won't work. I'm working on a smarter solution, but I didn't have the time yet to set default random layer IDs or whatever, but that's going to come. In any case, I'm trying to mimic the standard leaflet function definitions by including a group. So that lets you put different layers into a group, and those groups you can switch on and off, whether you want to see them or don't want to see them. Then you can set the opacity. One thing that is fairly specific to raster rendering using a leaflet extension called GeoRaster Layer for Leaflet, which was implemented by Daniel Dufour, the guy who gave the talk last week at Phosphor-G, is the resolution that you can set. I think by default I set it to 96, that's pixels, basically on your screen. And what that leaflet extension does is, depending on the zoom level, it resamples your data using a nearest neighbor method in order to put 96 or in order to put a few cells together into one cell, so you have a lot better experience without losing too much of the information. Because if you look at a really high resolution image and want to render every pixel, sometimes depending on the zoom level, those pixels are much smaller than the actual pixels on your computer screen, and that doesn't make any sense. You're losing a lot of efficiency when you do this. And so he decided to enable this nearest neighbor resampling when you zoom in, zoom out. And that makes for a lot nicer and better experience and of performance in the browser. And then there's an argument called auto zoom. If you set that to true, which is, I think, the default, then it will automatically zoom to the area of your, or the extent of your data that you put on the map. In our case, we're putting a global data set here, which is just the RGB representation of the elevation or whatever topography of the world from natural Earth data. That's a massive Geotiff file. So I've converted that into Geotiff, and I'll show you how I did this in the second part of this tutorial. But that Geotiff lies in this bucket. We pass the URL to the bucket, and then we see that we can interact with this Geotiff quite nicely, actually. It's not as fast as the tiles that are served by OpenLandMap and whatever other tiles Tom has implemented, simply because we're not using an optimized tile service server. We're just accessing a storage bucket on the internet. So there's no speed gains there. It's basically reading static from a static file that lies somewhere on the internet. But for that, I find that still quite impressive how fast it is, and it's still definitely something that you can work with enough, right? So here all the tiles get loaded, and there we are, right? And it gets better the more you zoom in, the easier it gets for the tiles to be loaded, because there's only smaller tiles and not so many tiles to load anymore. All right, so this actually works quite nicely, I think.
Lowering the resolution will make it even faster?
If we reduce the resolution, this will make it faster, yeah, but you will then end up with something that doesn't look nice anymore, right? I mean, this is now set to, I think, 256. Let's see. I mean, we can quickly do this with like 48 or something. I don't know. Quite low resolution. Let's try this. Let's see what that looks like. Come on, what's going on? So this is then what it looks like here, but it should actually render quicker. I mean, you always have to be careful when you do the comparisons in a notebook or in the browser. I mean, all of this is JavaScript libraries that are written for the browser, and they're not written for a browser in a browser like you have in RStudio, for example, right? So there's a layer on top in RStudio that slows things down as well. But yeah, so usually that makes it a lot faster. So it's nice to get a first overview, make it low resolution. And I think I just took the native 96 pixels per inch type resolution. And then that's then what the standard is. But you can go up to whatever you want, right? Yeah. All right. So this is a code that I prepared myself and uploaded to this S3 bucket. But using that add cog function, you can actually visualize any cloud optimized Geotiff that is out there on the World Wide Web. So here I'm taking one of the OpenLandMap layers at 1 kilometer resolution, some photosynthetic active radiation visualization. That actually also lies in an S3 bucket, apparently, because it's also S3 EU Central 1. And that is maybe something that you should keep in mind as well. We are in Bonn, Siegburg here, and the EU Central 1 sits, if I'm not mistaken, in Frankfurt. So that's where the data is actually hosted. So it's quite close. If you go to the US West Coast, for example, then it will take a little bit longer, and you will see that because the origin of the file server is quite a long way away, and all the data needs to go through the Atlantic, basically, through the cables, right? But you see here that, and I'm not sure what that is, maybe Tom can quickly explain what Wasabi Sys is, but as far as I understand, it's some sort of optimizer for tile serving that is put on top of the S3 bucket. So when you look at this file and you zoom in, that actually is a lot faster than the other one. And keep in mind, this is 1 kilometer resolution, and the other one that I showed is 10 kilometer resolution. So this file is quite a bit bigger than the other one.
No, this is storage we have. wasabi.
Okay, so it's not just the.
Just have a S3.
Okay, so it's not optimized. Well then,
But the file, the TIFF is optimized.
yeah, that's.
I don't know if we can boost the.
Yeah, I'm just trying to, I can check it later, but I think I used a bigger tile size. By default, it used 256 by 256.
I think it uses 512 actually, but I'm not
Yeah,
sure.
yeah, by default, yeah, you're right. And I think here it's double, so I use
Okay.
2024. So but I need to check. I think so. So I did some tests and it did improve. Like a bigger tile did improve for really large areas. The visualization.
Okay, that's good to know. I mean, when you look at the documentation for GDAL Translate for the Cog driver, you can do a lot of things. I mean, there's 10 different ways of compressing your data. You can adjust the tile size as Leandro just outlined. And there's a lot more options that you can set there, and some may lead to faster rendering, some may lead to slower rendering. So this is, I'm not an expert in this. I guess something that people just need to try and figure out, or just live with the defaults, which are, I think, okay, as we see up here. So the only thing I've changed up here is the compression size, because we're serving it via the internet. So the smaller the size of the data, the quicker it will go, right? And I mean, if you reduce the tile size, you're actually reducing the data size that is being served for a given region, right? So that actually makes a lot of sense. I'll keep that in mind. But in the end, this add cog function should work with any and all cloud optimized data sets that are somewhere on the internet that you have access to. I mean, if they're not publicly available and you're not allowed to read them, then you can't visualize them because you're not allowed to read them and transfer them to your browser. So that's one of the caveats. At the moment, that's pretty much all this function does, is depending on the number of layers. If there's 3 layers, it will automatically try to render that as RGB images, as we see here. And if there's only 1 layer, as we have here, it will render it in grayscale for you. I'm working on the ability to pass different color scales to it, which shouldn't be too hard. But there's one thing that I'm still not sure about how to solve. And that is, if you, for example, take a 11-band Sentinel-2 image, or I think it has 11 bands. Excuse me. And you want to render the NDVI, for example. I mean, you're accessing the raw data, and nothing is done in R. So we have to do all that calculation in the browser. So we can either say, okay, I want to see the NDVI, then we assume it's that and that and that band, and we subset it and then calculate the NDVI and then render it. But it would be quite nice to be able to provide functions that you define yourself as an R user and use those to do whatever calculations between the bands you want to do, right? But I'm not quite sure how we do this. I have a few ideas, because we need to translate whatever the function or calculation is that you want to do, then from R to JavaScript. And those are 2 completely different programming languages. So it's not that easy to do this. But I'll keep working on this. And if you have any ideas, if you have any feature requests, just go to the GitHub repository of Leafham and let us know that what you want, and we'll see if we can implement it. And if there's any people that know JavaScript quite well, I'll be happy to hear from you as well. And I take collaborators for this, definitely. Yes?
But on the JavaScript side, it's possible to just do custom calculations.
Yes, I know.
Next question, is it?
Yes, it is. There's a Math.js library that basically gives you pretty much all the base R math functions that you have or want. So it's limited. There's a bit of a difference there. Obviously, if you load any special library that provides special functions that you want to use, that's very likely never going to happen. But basic calculations like an NEVI, which is just adding and dividing and multiplying some layers, then that's definitely fine, right? That is easy to do, but you lose a lot of flexibility if you restrict it to a few calculations, right? And that's what I always want to avoid, because then you're back at the point and click software of the GIS system, where you can do minimum, maximum, and standard deviation, and that's pretty much it, right? So the beauty of having a programming language is that you can do a lot more of this, right? But getting that translated from R to JavaScript is not trivial. I do have, as I said, a working implementation for basic math for a different function. So I could, I guess, easily port that, but I'm still not too happy with the implementation. So I might just think about this for this specific use case a bit more. All right. Are there any questions regarding raster visualization from R using cloud optimized geotiffs stored somewhere on the World Wide Web? If that is not the case, then
Try maybe with the 10 meter.
Sorry,
The whole Europe, the 120 gigabyte images.
I did, but I think there is a course header conflict. I wasn't able to read it. So in the browser it said course restriction, so you can't do the same thing from, or two things to, you can't load two different things from the same web page. So we need to talk about this.
Okay.
Right, then I'm going to move on to cloud optimized vector data, and there it gets a bit more complicated. There's not only one function, there's actually 3 functions for Pm tiles and 1 function for flat geobuff. As I said, the flat geobuff implementation has been had been around for a while now, and is used as the default mechanism to visualize your data in the map view, unless you specifically switch it off. Now, Pm tiles, and I don't want to go into too much detail here. Pm tiles is basically the format that is optimizing what are called Mapbox vector tiles, which is a standard that the Mapbox company has implemented or created. And Pm tiles basically puts a little bit on top and to optimize the serving for visualization. So it's really about visualizing the data. We have the same thing. I put up a vector tiles data bucket. If we run this code, then we see there's a few more data sets in there. One I called DE points. That is actually the biggest data set that we have here. That's 15 million points taken from Geofabric, nightly snapshot of the OSM dataset for Germany, and it's the whole points layer. So all the points in OSM that exist for Germany are in this file. Then we do have a layer that I called NZ building outlines. Those are all the building outlines in New Zealand, as provided by the Land Information Service of New Zealand, LINZ. And then there's all the rivers in Africa that I downloaded from a certain place, and that is all. I'll send around the documentation of how to do this and where to get the data from later on. And apart from the DE points, which I only have in Pm tiles, I have the other 2 layers as Pm tiles and as FGB format, so flat geobuff. And I'll show you why. Because creating vector tiles is a very costly and time inefficient or time costly exercise. Because you basically need to cut up your vector data into small tiles. But then with raster, that is quite easy because you just cut them at a certain edge of pixels, and then you're in the next tile. With vector data, it gets a bit more complicated because if your polygon extends 2 of your tiles, then you have to actually not only cut it, but close those polygons again and make sure that those lines that you created there are actually not being visualized when you render it, because otherwise you're creating a new data set, right? So that's why it is a lot more costly to create vector data, tile data, cloud optimized, than raster data. The flat Geopath generation is actually quite cheap. It's a GDAL driver. You can just go Augur to Augur or OGR to OGR with your input data file and your output data file, or it's the other way around, I think. It doesn't matter. So you can convert a geo package to a flat Geopath or a shapefile to flat Geopath. That is relatively quick depending on the size of the data. So that is a very easy conversion. And that is in itself a cloud optimized data format that is streamable. So it has the ability to that you can make what they call HTTP range requests. So you're only looking at the header of the file where the index is stored, and then you know exactly which part of the data file you need to serve for your current viewport of your map. So it's not going to download anything else that you don't see on your map. It's just going to download the parts that are in your map. But that's also where it gets a little bit tricky, because it's in that sense optimized that you can cut out different bits and pieces of the data and serve only those. But if you have a large file and everything is in your view, then it will by default load the whole thing. And it's not optimized in a sense that it is somehow in pyramids for different zoom levels. That is not the case for flat Geopath. So always be careful with this. That's why in that function add FGB, you can set a min zoom and a max zoom argument, and it will only start rendering once you're at min zoom or higher zoom levels, and it will stop rendering at max zoom, which you don't have to do, but that was easy to implement. So, and it makes sense to have both in the end. So be careful when you have a big flat Geopath file and you want to render it, make sure that you could either set up your map that you are not allowed to zoom out any further, that you can do with Leaflet. So then you don't have that problem, because you make sure that the user cannot zoom out any longer or anymore. Or you say, whenever I'm zoomed out too much, just don't render it anymore. And that's what we're saying here, right? So we're accessing, in this case, the flat Geopath file from Africa, of all the rivers in Africa. But we're saying only start rendering at zoom levels of 6 or higher. So now it gets tricky, because I don't think you can see that very well. Up here, you see this little gray stripe where it says the coordinates of where you are with the mouse and what zoom level you're at. I can't make that any bigger for the crowd, sorry, that's just not working. So at the moment, we're at a zoom level of 2, and you see that you don't see anything on the map. So if I now zoom in, zoom level 3, let's go up there. Why is it not coming? There it is, zoom level 3, zoom level 4, 5. And now if we zoom in one more, we should start seeing the data being rendered, right? And there it is. So that is then basically fetching only the data that is in this current view and putting it on the map. It's getting redrawn every time you finish a move on your map. So the whole thing gets redrawn.
And if you zoom in, it gets faster and faster.
Yes. If we zoom in more, it gets faster and faster. well, if it knows where to look. I think, now we're at zoom level 11, and I said max zoom level is 10, so it doesn't render anymore. But here, if we are here, then it gets really fast, right? So the idea here is to be able to combine vector tiles that you create, and that takes quite a long time to create, and at higher zoom levels, because it's the high zoom levels that are really time intensive to create the vector tiles for. And at high zoom levels, you can actually use the flat Geopath quite well. And this is basically what we're doing here. So that idea is, in the end, something that you can combine, right? So you have a PM tiles, vector tiles, cloud optimized format that takes quite a long time. We're going to create one later on and see how long that takes. So the information about this is basically that you have a min zoom of 0 and a max zoom of 5. There is, however, I found out actually it renders until a max zoom of 7. I'm not quite sure why that is. Either it's a bug in the software or it's just not reported correctly here, but it is rendered until a maximum zoom of 7. And then what we do is we add those Pm Polylines to our leaflet map and say we want to render them in color blue. And then this is what we see here. So if I actually go and reload that page, then you will see how long it takes for the thing to actually be rendered. And that is now using the optimized PM tiles at a zoom level of 2. And if you zoom in, it'll refetch the data or the zoom level tiles for the zoom level of 4. And if we zoom in any further, then you will see that it just fetches all these tiles. And the closer you zoom in, the more performant it becomes. So at the moment, we're at a zoom level of 7. And as I said, if I zoom in one more level, then they're gone, because that's the maximum zoom level that is set at the creation of those tiles. So what we can do then is put these two together and say, well, let's render the cloud optimized PM tiles. And from a zoom level of 8, we start with the flat Geopath rendering, right? Because then we zoomed in enough that it is performant enough to do this. So in order to showcase this here, I kept the PM tiles data in blue and render the then flat Geopath data in black. Okay, so here we have our blue tiles at the low zoom level. And if I now start zooming in here, then it'll fetch the tiles according to the zoom levels. And one more, and again one more. And then at some stage, it will then switch to the flat Geopath and fetch all the flat Geopath data. Okay. One more thing that is really nice about these implementations of those two standards is it ships with all the attribute data as well. So it's not only the geometries that get fetched, unless you only include the geometries in your files, but if you have attributes in your files, that'll get fetched as well. And you can, just like with map view, click on any of those and get all the attributes that are from that geometry, basically, at this segment here. And the same is true for flat Geopath. Once it renders, if it renders, it should render. Yeah, there we go. So if we click on one of those, we see the same thing, because they are included and get fetched as well. So that's, in my mind, quite a neat way of being able to show your data from very low to very high zoom levels for quite a lot of data. One thing to keep in mind is whenever the map moves and you render flat GeoBuff, that is, I guess, my lack of understanding of JavaScript at this point, the whole scene gets redrawn. So if you open a pop-up too close to the edge of the map, then it will try to fit that pop-up into the map, hence move the map, and then the data is gone and the pop-up is gone. So you could do this all day long and it'll disappear all the time. So you need to make sure that whenever you want to click somewhere, you need to make sure that at the moment, you need to make sure that the pop-up actually fits in the window. And that is also why I made this map here a little bit bigger, because I found out the hard way when I rendered it that, okay, this doesn't work as I want it to work. So
how big is this file on the hard disk?
This file on the hard disk is, you mean the flat GeoBuff file or the PM tiled? PM tiled is, let me quickly see, it is here. So the PM tiled file is just 37 megabytes. The original file that I downloaded is the shapefile here. So 39 megabytes, not very much, but I'll be showing you, for example, the building outlines where we have as a flat GeoBuff 1.8 gigabytes and as a GeoPackage 1.4 gigabytes, and as PM tiles, because you can gzip compress them, it's only 360 megabytes. So that's also nice because it saves you storage on your cloud storage.
I will play with the maximum. My laptop goes.
Okay, with how big is your data then?
No, I mean, doing your example.
Ah, okay. Okay.
Just probably.
Maybe you have too many tabs open on your laptop. I don't know. Yeah, because I mean you have one browser right for doing these things. So okay, so much for that. Then one thing that is quite nice, and that is, I guess, something, Tom, for you regarding your questions yesterday in the GeoArrow session, where I alluded to that there is quite a nice way of preparing lots and lots of points to be able to keep the structure and then on higher zoom levels render more and more of those. This is what I've done with the German OpenStreetMap points layer for all of Germany that I downloaded from Geofabrik, and that is about, how much is it? OGR info, we have 15,370 odd features there. And as I said, as a flat GeoBuff, I'm not sure how much that one is. This is only because it's points, it's not, oh yeah, as a flat GeoBuff, it's 3.4 gigabytes, that file. And as a PM tiled, because you gzip it's only 500 megabytes. So now for that, we use a software that is called Typicanu. I'm not going to go into many details here, but what you can do, and that is basically creating the vector tiles before you convert them to the PM tiles format, right? That's the Mapbox software that was created by Mapbox. It's a C program, or at least C++ program, so it's quite optimized for speed. And it has millions of options. I'll show you later on. But what I've done here is basically set an option that says cluster densest as needed, which makes for points a lot of sense. If you have a lot of points that are a meter apart and you look at it at a zoom level of, I don't know, where you see the whole world, then you won't be able to distinguish those points anyway. So it's just going to cluster all these points together and put one point on the tile that it creates for this zoom level. So that saves a lot of space and without losing any information for you to visually decipher when you look at the map. And then it's basically doing that for every zoom level, for every tile. And if it finds out that it is still dropping features, even though you're at the zoom level where you said this is the maximum zoom level that I want to create this for, and in this case, I've set the maximum zoom level to 14. Remember, standard leaflet map has 18 zoom levels. So 18 is the highest zoom level, sometimes 19, but usually the standard is 18. So I said maximum zoom level should be 14. But you can then tell the software, and it's trying to figure that out automatically, basically, to keep extending the maximum zoom level if it is still dropping, or in this case, clustering features together because they are too close together. So you're not losing any information at even higher zoom levels, right? And the result I find is amazing, really. So let's get rid of this one. And for that, we have a function called add Pm points, works the same as add Pm polylines or add Pm polygons. You just pass the URL of the Pm tiles file in your S3 bucket. You can have some paint rules, and this function is called paint rules because in the JavaScript implementation for rendering Pm tiles, they're called paint rules, so I just adopted that. You can set fill color and the stroke color, you can set the radius of your points, and that is all then done on rendering. So that's not done at the creation of the files. That is really done when they are rendered in on the fly, in real time in your browser. And this is basically what it looks like. So these are 15.3 million points for Germany at a zoom level of 4 at the moment. Remember, I said maximum zoom level should be 14, just because I thought that would make sense. Doesn't matter, it also has an option to guess the maximum zoom level, but I'll talk more about that later. So if we zoom in, it'll then render different tiles at different zoom levels. And then I'm going to go into Berlin because Berlin has the highest density of points here. So if you keep zooming in and zooming in, it's really quick and fast. And at some stage, you start seeing all these really tiny details of streets and whatnot. And it just goes on and on and on forever, because apparently at a zoom level of, where are we now? 16, so 2 zoom levels beyond what I said should be the maximum zoom level, we're still seeing points, right? Because apparently they're still so dense that they are still being dropped. And then at the final zoom level of 18, you actually have all the points here. And as I said, all of these points carry also their attributes. For OSM, that is usually a very mixed bag. Some of them have many attributes, some of them only have the OSM ID, which is like the minimum that you need to provide. And I've dropped one attribute feature because it just extends way too long in the pop-up. And yeah.
Just one question. So, but for areas where you don't have like such high density of points and supposedly stops in 14, if you continue the zoom, in the client side, it will use the last available zoom, or you will not see any point?
Well, that I'm actually not quite sure about, because if you say, I mean, here I think I said guess the maximum zoom level, and there it actually stops rendering when you zoom beyond the maximum zoom level that it guessed, right? Reported here is a zoom level of 5 as a maximum zoom level, but actually you're rendering until a zoom level of 7. So I'm not quite sure what's going on there. But the guy who implemented all this is called Brandon Liu, I think, or Lee, I'm not sure. He also presented that, I think, for maybe the first time at Phosphog last week. So that's a very, very young project as well. And he's at the moment I do have that output here. So here it says PM Tiles spec version 2. He's currently working on spec version 3. So a complete rewrite of the spec, which will then again mean work for me to re-implement everything, but I'm hoping that it'll be an easy transition. But so it's a very young project, so there may be bugs in there, or it might just be my misunderstanding of things. I'm not sure, but setting that maximum zoom, for example, is a typical new thing. Typical new was abandoned or like is not maintained anymore by Mapbox. So that guy that created PM Tiles ported the whole thing over to his repository and is now maintaining that and adding features to typical new as he needs them for his projects as well. So it's a typical open source kind of evolution of things.
But I think that's great. It's really fantastic, and I think in the way that you are present now, it's more like it's a decision on the user side. So
yes.
For example, if you have a data that you don't need all the zoom levels, you can just block the leaf map here to stop at some like zoom level, right?
Yeah.
But if you have another data, okay, here I need to really go crazy and generate all the zoom
exactly
possible, so you can play with that.
I mean, if you count ants in a 1 by 1 meter square, right, then you will have a very, very high resolution data set with millions of points that you need to be able to zoom into quite a lot, right?
Yep.
So, I mean, that might actually be beyond the capabilities of the software, but just as an example. Yes, and then you might have different layers, and one layer is actually, all the detail is visible at zoom level of 7, because it's a worldwide data set that is quite nicely distributed. But then if you want to have all these clusters like Tom showed in Florida for the USGS, whatever data collection they did there, then you want to be able to zoom in there more. You can either do that with 2 different layers or do it that way, that you just extend the zooming if there is still detail to be gained, right? So, but I was amazed when I saw this, how well this actually works for 50 million points. I mean, that was my dream when I started MapView, to be able to visualize that amount of data, and it's really responsive. You're not losing any, you don't have to wait for anything here, right? And it keeps, as I said, if you zoom out, it keeps the rough patterns of the big cities in Germany, and
it's very fast. 150 million points.
No, 15 million points.
15 million.
Yeah.
And I tried loading, dropping it in QGIS and QGIS, the PM tiles. But can you read the data PM tiles? Can you use it just also to access the values? No.
No. But the good thing is, or the maybe good or not so good thing is, you can, in order to create the PM tiles, you need to either have a GeoJSON representation of the data or a flat GeoBuff representation of the data. So that's the only 2 input formats that typical GNU can work with. The guy from PM Tiles actually added the flat GeoBuff capabilities. So for the original typical GNU, it's only GeoJSON, because they only care about web mapping, and then they say, okay, it's GeoJSON. But so that,
you can read in our
yes, flat GeoBuff you can read and get at the data where you want to, basically. So that's
the next thing will be to add that to GDAL, right? And then it should be
that is yeah, then you have it definitely. I'm not sure what the plans of the ProtoMap guys are, whether they want to have it in GDAL. I guess flat GeoBuff is a perfect example that if you provide a GDAL driver, then your data format actually takes off.
And so this PM tiles, how old is this? How old is this thing?
I'm not 100% sure, but not more than a few years. That whole thing.
Yeah. Constantly need this.
Yeah.
It's amazing,
Yeah. And you can actually overlay both, right?
Yeah.
Easily. You have a cloud optimized Geotiff in the background and have all the points overlaid there. And it's still very, very responsive. I mean, here it's the Geotiff that is hindering the performance. But in the end, I guess that is for you, if you want to show all your sampling points, your millions and millions of sampling points, then that's pretty much one solution that you could take straight out of the box. So, all right. As anticipated, that whole tutorial about visualizing things from R is pretty much at an end. If you are interested in more options that you can use, one thing I should say, add Pm Polylines, or when you create polylines that have a lines data set and you want to use these options with Typicano, where you can, there's a few of them where you can cluster the densest, or you can drop the shortest as needed, or drop a few other things. Then it all depends on your data. I did that with the Africa rivers data set, but then at low zoom levels, because it's dropping a lot of these rivers, it just doesn't look like anything anymore, because it just has random arms of any river that it kept, because it's dropped all of the other segments of the river. So there you would need to prepare your data in a way, I guess, that it actually has one line string instead of multi-line strings, or multiple line strings representing one river. So then it would work, because then it would keep only the longest ones. So at low zoom levels, you see only the major rivers, and as you zoom in, more and more of the little streams pop up, basically. But that was a tricky one, and I didn't have enough time to actually come up with a proper example here. Because I didn't create any of this data myself, I just downloaded it from different bits and pieces, and then converted it to the things I wanted.
Do you know how it works, like for polygons? It's kind of simplified the polygon in the different zoom levels.
It's again, you have the option of clustering. I think is only valid for points, but dropping denses as needed is one option, and there will basically only keep the largest polygon if they're too close together. So because then the small little polygon that is next to the big one you don't care about anyway. But yeah, as I said, there's so many options there that I wasn't able to try all of them, because it takes time to create these things. But I'm sure, Leandro, you can have a few more days now with testing and benchmarking these things, and maybe give us an update next year in the summer school of how that is going and what you think should be the best standard defaults for creating these things. So are there any questions? Are there maybe any questions online? Where do I find those online questions? Or
and the only thing we will have a problem with this point.
oh, there's only 4 participants anyway, so
This is great, but the only problem we have the time to be able to also show how points change the time.
okay.
Yeah, that's the only thing that I don't see now. Otherwise,
No, but the guy is very responsive. I have a very active Twitter mail conversation with him, because I don't know JavaScript that well, so I have to ask him all the time how to do this. Is this possible? Blah, blah, blah. And he's very, very responsive. So
yeah, in this case, it's more like a design issue on the client side. Because, for example, you can have multiple of these PM tiles, one per year, and you can just scroll per year and change. Because I think the big difference here is actually like the rendering on the client side. So instead to have one file, you can have like one file per year and just scroll the same way that we did.
we have like millions of points, scientific points that we would like to share that people can visualize in this project, but they have a time attached. So like meteorological stations, you know, this ISAT, JD, the land cover change points, for the data, but they all have a time. So
then for now, I would say that is definitely a viable option to have for each time step a different layer that you can then just visualize. switch on and off with the slider. It's more work on the back end, more.
Actually, it's the same structure for the out of cloud optimized Geopath. They just replicate for the.
And yeah, I mean, what's really nice is if you look at the file sizes of these things. Okay, so downloaded was, this is the latest German OSM PBFF. It comes from GeoFabrik. So that's all of the snapshot of everything that is available for Germany, including polygons, lines, and points. That is highly compressed, I think, 3.9 gigabytes. Then you convert that to flat GeoBuff and only the points. So flat GeoBuff is not the best format for storage, 3.4 gigabytes. Then you convert that to the MB tiles, and that actually makes it already only 500 megabytes, right? And then with compression, you gain another, I don't know, 80, 70 megabytes, because compressing points doesn't really do much, right? But effectively, you're cutting your data size down to quite a bit as well. So I really like that thing. And I do have a visualization of polygons actually here that I can show straight away. So this is the building footprints in Auckland, Leandro. And if that is basically what you would see. I didn't do any setting any of those cluster denses as needed or something, but this is basically how it works with polygons. So it still has all of them there. Or actually, I did try with cluster drop denses as needed, but that then actually really looks very scattered at zoom levels where you feel you should be able to see more. So it's a matter of playing around with these things, right? But I mean, this is 3.5 million polygons or 3.2 million polygons, and it's ridiculously fast, and you get all the feature information for every building there. So
and you have full flexibility, for example, to play with this style and this
yeah,
stuff, right?
pretty much. Yeah, pretty much. As the style gets applied at render time, so you don't have to have polygons in blue as a file, polygons in red as a file, and polygons in green as a file. You can just do that at render time, or in R at creation of the map time, basically. So yes, any other questions regarding this?
If you have your own bucket with things in it,
Yes.
and you don't want to make it public, how would that work with credentials?
Well, AWS basically provides you with a .aws folder on your system, and there you have default credentials, or for different accounts, credentials stored in there. There's always an access key, a secret access key, and a region that you need to supply. In R, using the pause package, you can set that actually as an environment variable. So sys.setenv secret access key equals blah, 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 and then you have access from your R session to the contents of that bucket. If the access content list or something, ACL, it's called in AWS, enables you to view or download the things. I mean, that is all stuff that you need to set up in AWS. And I'm not going to go into any details regarding that. If you're really interested in it, I can show you offline, but I'm not going to include that in the tutorial because it doesn't have to be AWS S3, right? You could host it on your own server that sits in your living room and is connected to the internet and has a URL. If the data is there and you have access to it, then so be it. I mean,
you have to set up a bucket system.
You just have to save the file at a location that can be read via HTTPS. That's all. So FTP server works fine as well, I think. So I'm not sure whether FTP actually works, but not that I'm saying something stupid here.
It should work. Like even like a, I don't know what Bash can just post the file on a web server. But it's better used as S3 because it's like you don't have something run, you don't have a server file.
Yeah, so it's cheap. I mean, it just
You could even host it on GitHub.
yeah, you could, I guess, could do GitHub IO.
Yeah, you need to have the support to get that request date, you range the request, and some servers. Zenodo, yes.
Zenodo, yes, no, but slow.
Oh, okay.
Very slow, but they changed it. One guy just had to report that something. It took them 2 years, there was an issue on GitHub. But now they support, but it's slow.
Yeah, S3 is fine, I think.
One question, so can you apply filters like on the data? Instead to plot all the points, you can just plot the points with a very specific attribute.
Not sure. We can have a look.
Because you have the data, right? With the client side. So if it works, it might be a good solution also for the time. Because instead to have multiple files, you can have just one file and plot, you know, file like points from 2020.
So there is examples in here somewhere. Maybe there is one where you can filter. I don't know. What is those? TP sample? I don't know. No, not this one. No, it's pure tight. There's something here. No, it does not. Well, actually, maybe, I'm not sure. I'm really not sure actually, but I guess so, because I mean, you're just visualizing it.
Yeah, you can even
In the map.
download and just
Even if the whole range is there, whatever you visualize then is just normal leaflet JavaScript, right? So I think that should work here. I'm not sure from the top of my head how, but I think it should work.
You have a code for all your examples. Is it somewhere?
The code for all the examples is in the second session, yeah, basically. So that's.
I mean, sorry, the OpenGeoHub files you use to generate.
Oh yeah, I'll put that up in a. I don't have a dedicated repo yet, simply because I was working until yesterday to get it all done. But yes, I will put it up in a GitHub repository and share that. All right. What shall we do? Shall we continue with the creation for another 10 minutes, or shall we have an early break? I don't mind. I mean, we have more than enough time later to go through this.
We can do break and then we'll cut.
Okay, that sounds like a good idea to me. Perfect.